Today we'll be taking a look at the calculation of oxidation numbers in ionic complexes. Okay, so the first I'll teach you how to calculate the valency or the oxidation number of one of the ions in the ionic complex. So the first ion I'm going to use as an example is manganate ion. It has an overall valency of -1, and we want to find out what charge or what valency manganese is expressing whilst trying to attract and interact and bond with four nascent oxygen atoms. So we'll have to use the following mathematical method. MnO4 equals -1, whereby I would make this X, and then I already know that the reacting valency of oxygen is almost always constant, which is -2, so I'll multiply 4 times -2, and then it'll be X plus 4 minus 2 equals -1, and you can then solve from here for yourself. So it'll be X plus 4X, 4 into -2, that'll be -8. -8 equals -1. So if I take that to the other side, it'll be 8 minus 1, 7, and the reacting valency of manganese ion for this manganate complex to bond with 4 nascent oxygen atoms would be +7. So it'll be because it's a metal, it has to have a positive valency. It's a transition metal, block B element. The second one we'd like to take a look at is the very ubiquitous bicarbonate ion. That's part of sodium bicarbonate, potassium bicarbonate, and it bonds with rare earth elements and alkaline metals. So we'll use the same formula because we want to find out what valency, what oxidation number carbon's reacting with whilst trying to bond with 1 hydrogen atom and 3 nascent oxygen atoms. We'll use the following, the same procedure as we did for manganate, and here it would be HCO3 equals -1. And then we know that it's +1, hydrogen is +1, plus X plus -6 equals 1. So it'll be 1 plus X and -6 equals 1. So 1 and 1 cancels, and we take the 6 on to the other side, it'll be 6. So we can find out that carbon in this anionic complex is reacting with an oxidation number of +6, not -6, +6. And then the third ion I've got is phosphate. Very naughty, very it's a very important ionic entity, anionic entity, and it has an overall charge of 2-. So phosphate would be 2-, and we want to find out what valency phosphate, what oxidation number phosphate is reacting with. So I would do P plus 4 into O equals -2. Okay, so if I have to show working in the exam, I would use this working. It'll be X -8 equals -2, and I would get PO4. Yep, so I would get X equals 6. Usually phosphate is either 3 or 5, but in this case, because you've got a little bit higher number of oxygen atoms, a little bit more than usual, trying to attach with phosphate, giving it a high electronegativity and a high molecular radius. Ionic, not ionic, but well, technically ionic, but it's a molecular radius. So here phosphate's oxidation number goes up from 3 to 5 to 6, and it has to be +6 in this case. So the next would be the next the entity I'd like to calculate is chromate. 1, 2, 3. Yep. So chromate, CR O4 with an overall charge of 2 minus. And then I will use the same method to calculate and find out the oxidation number of chromium. So it'll be chromium plus 4 into O equals minus 2. And so it'll be X minus 2 times 4 equals minus 2, and then X minus 8 equals minus 2, and then X equals 6. So the oxidation number of chromium would be plus 6 here in this case. X equals X equals 8 and then minus 2, and then you subtract it algebraically to get the oxidation number for chromium, which would be plus 6. So it's using the oxidation number of plus 6, the variable valency, which is a characteristic of the transition metals D block elements. It's using plus 6 oxidation power potential to attract 4 nascent oxygen atoms. Okay, so going to the next variable of chromium is dichromate ion, which is also a divalent inorganic anion obtained by the removal of both protons from dichromic acid. It's a chromium, I don't know how to say this, but a chromium oxoanion, and a divalent inorganic anion. So it's an anion. And it's a conjugate base for hydrogen dichromate as well. I hope you got the message. So the overall valency is two negative because it's divalent, anionic and divalent. So the equation would be Cr2O7 equals minus 2. It would be 2x plus 7 into minus 2 equals minus 2, and that'll be 2x minus 14 equals minus 2, and then it will be we take this to the other side, and then we get 2x equals 14 minus 2 equals 12, so 2, and then x would be 6. So we can see that the valency for chromium in dichromate ion and in chromate ion was the same. So it's using the same plus 6 oxidation number to attract a varying number of oxygen atoms. So then I'd like to take a more complex example. A more complex example would be of a neutral salt compound, which would be cobalt, 2 nitrate, which is denoted as cobalt 2 nitrate. And what would happen here is that I would do so cobalt 2 nitrate equals 0. So in this case, before I can find out the valency or the oxidation number of cobalt, I'll have to find out this one. So I would take nitrate ion out, and it would be minus 1, and then I would find out the oxidation number of nitrogen prior to finding out the cobalt oxidation potential number. That would be 6 minus 1 equals 5. So we know that a nitrogen is operating at an oxidation number of plus 5. So then I would input this here, and then I would do cobalt plus 2n plus 6O equals 0. So that will be x plus 2 into 5 plus 2 in 6 into minus 2 equals 0, and that would be x plus 10 minus 12 equals 0. It would be x equals 2. So that would be it. So I have found out that the operating oxidation number of cobalt for the compound of cobalt 2 nitrate is 2. I mean, I knew it from here, but you know, I've just mathematically verified it as well. So I hope this helps. We looked at many compounds. The first one was manganate, then bicarbonate, then phosphate. Then we looked at chromate, dichromate, and then we looked at cobalt 2 nitrate. I can quickly do sulfate as well, SO4 2 minus, and in this one you can see that it would be S plus 4O equals minus 2, and it would be S plus 4 into minus 2 equals minus 2, and that would be S plus 8 minus 2, sorry, S equals 6. So sulfur is operating at the oxidation number of 6 whilst trying to attract 4 nascent oxygen atoms, and that's giving it an overall conjugate valency of 2 negative. So it's a divalent anionic entity. I hope this clarifies the topic of how to calculate the oxidation numbers at A levels and post 16 curriculum, and it's useful for BTEC, HNC, HND, and A levels, and all post 16 exam papers. Thank you very much for watching. I hope you have a lovely day. I hope you learnt something, and if not, please ask me any questions in the comments section and I'll try my best to answer it. Cheers, take care, bye now.